and welcome to the GI Technical Session 1. Today we've got Robert Lawrence with Beyond Engineering. Robert is a geotechnical engineer with over 14 years of professional experience. His passion about advancing civil engineering and geotechnical engineering while helping others achieve success in their professional and personal growth. As the geotechnical practice lead at Beyond Engineering and Testing, Robert oversees geotechnical engineering and drilling operations across Texas. His responsibilities include developing new business opportunities and implementing innovative and client-focused solutions. Robert has led and contributed to major infrastructure projects across the United States, particularly in the transportation and water sectors. Notably, regional projects include the North Haven Hike and Bike Bridge over US 75 in Dallas, the 27 miles of large diameter pipeline for the North Texas Municipal Water District, Lower Bodark Creek Reservoir, 16 miles of new railroad alignment for the Dallas Area Rapid Transit Silver Line, which just opened, by the way. And so, congrats. And then he is a lifelong learner. Robert has earned both his Bachelor's of Science in Civil Engineering and Master's of Science in Geotechnical Engineering from the University of Texas at Austin, where his graduate research focused on the development of geotechnical spatial database systems. He is currently pursuing his executive MBA at the University of Texas at Dallas to enhance his ability to deliver strategic value to the geotechnical industry. Welcome, Robert.
Thank you. All right, we have a good crowd here today, so I'm going to keep it pretty interactive. So if you'll have questions throughout the presentation, let me know. As it says on the slides, the goal is to give some of the key differences that have changed in the TxDOT Geotechnical Manual. The new LRFD manual that came out coming up on 2 years ago now is April 2024. And then kind of talk about where I think some of the future of geotech is going. I'll preface, I don't work for TxDOT. TxDOT did not condone anything I put in here. And also some of this is opinion-based, so just kind of want to get some discussion out of the group and see how it goes. So with that, I put, that's weird. There we go. I put some references in here, and I just want to point out a few things. If you haven't seen the new LRFD manual, you don't need to read these, but they're here in case you get the slides later. Obviously, the new manual is online and available. It does reference the AASHTO manual, specifically the 9th edition. That is not available for free online, so you do have to go get that, and it is pretty heavily referenced. You'll need that to do a lot of the LRFD calculations if you're going to follow that manual. They do reference also FHWA, drilled shaft, and German pile manuals as well. So just want to point out that this manual has a little bit more broad, references to it, to how you're going to be making your recommendations for geotech. So it is important to understand how that's going to tie together. So this is the cover of the new manual. Geotechnical LRFD out of the Bridge Division. It was April 2024. We'll probably be seeing another version of this coming out not too far out, as they're coming up on their 2-year cycle where they like to do a little refresh. So I know people in the industry have had some comments, had some questions, some things going back and forth. I anticipate a lot of those will get answered. So I'm not planning to talk about a lot of those parts of the presentation today, more just giving a lot of the big level highlights of what has actually changed from the previous version that we worked with to today. So that'll be what we're mostly focused on. So I think, question in Texas anyway is why now? We've had allowable stress for so long. We have these Texas cones, the swing core model. It's been working great. Why are we moving? Well, LRFD is not that new, right? What I kind of found as early as the 1960s is when some of this development of it started being talked about. And then, of course, AASHTO released their LRFD for geotechnical purposes in the early 2000s. So they had started it for bridge, incorporated geotech into it. So it's been around for some time as far as the U.S. goes. And then, of course, FHWA's different LRFD manuals started coming out 2007, 2014 to incorporate LRFD design into their models as well. And Bridge Division, for bridge design, at TxDOT, has been doing this since 2006. So there's been a disconnect, right? So we've been designing a lot of our structures with LRFD design on the top side, but the geotechnical part was being designed with allowable stress. So what you'll know about LRFD design is there's different load types: service loads, strength loads, extreme loads. And there was always kind of this battle of, with the structural engineer, geotechnical engineer, well, should I use a strength load when I'm using your allowable stress? Should I use the service load? There was guidance in there on how to do that, but we were still kind of meshing two different design processes together. So it was important for, I think, TxDOT to move this way. And it's not something that TxDOT's on the forefront of. Most DOTs in the US have been following this for some time now. I'm just going to point out, I'm sure you can't read all of these slides, but we're going to just quickly go through allowable stress versus LRFD. Some of you may be familiar with this, but it is important to understand what the difference is. So I'm going to take just a second to explain that for anyone that is not familiar with it yet. So allowable stress on the top side, you're taking your dead loads, your live loads, just combining those loads together, and then comparing that with what the resistance is. This is the capacity from the soil, and applying a single factor of safety, right? That's what we've seen in our calculations: factor of safety of 3 for bearing capacity, factor of safety of 2 for skin friction, or whatever our different guidance is. So that's as simple as it is. It's a very easy design. Add up your loads, see what your resistance is, apply a factor of safety so we all sleep at night and we're not worried about anything falling down. Load factor resistance design is trying to get a little more detailed, right? We're trying to be a little bit more intelligent on how we're looking at these different loads in different cases. So we're summing up our dead loads, but we're adding a load factor to that as well. We're summing up our live loads, but we're adding different live load factors to that as well. And then we have this resistance factor that we apply to the resistances. So the idea is we're customizing these designs, right? So if we're looking at the live load of trucks, we might apply a different load factor to that than we would if we're looking at the live load of the concrete. Concrete's not going to have as much flexibility in its change in load, right? So, but the trucks, you may see one of those trucks hauling down the highway with twice the load they should have on their vehicle, because it happens. So this is us trying to get a little bit better at applying those different resistance factor or load factors on the load side. And then on the resistance side, in geotech, we're trying to be more intelligent about how much we know about what's underground, right? When we know more information, we can be more confident in that resistance factor, and then therefore can apply a lower resistance factor to that model versus if we don't. Allowable stress did do that some, so I'm not going to discount that entirely. We did try to look at different cases where, hey, you can lower the factor of safety if you do this kind of test in the field. But load factor resistance design, I think, does a better job holistically looking at that across the board. So that's the big difference between the two. We're just breaking the loads up a little bit more and trying to be a little bit better about how we're applying resistance factors to those to the resistances from the soil. Another thing that's big to change in the manual is the boring spacing. Mostly it did not change at all, honestly. It's mainly with the bridges. So in the old manual, if you're familiar with that, it was every 300 feet. Doesn't really matter what the bridge looks like, how long it is, where the bents fall. You just go every 300 feet. We check the box. We've got enough data to cover the bridge structure. In this case, we're now we want a boring within 100 feet of the center of each bridge bit. So it's being a little bit better about us getting data that's actually closer to the structures we're designing for. Also for monoshafts, we need to be sure we're getting borings within 50 feet of the monoshafts, as there's going to be less redundancy with those structures. We want to be sure we have better soil data that's accounting for what's going on at those foundations. So this is going to mean some additional bridge borings probably in our longer bridge projects. But, fun fact, most bridge bents are about 120 feet apart from each other, right? So in a lot of cases, one boring will cover 2 bents. Now, what's interesting about this is AASHTO actually would push you towards getting a boring every bent. So this was TxDOT trying to give a little leniency, right? Not pushing the industry from wide spacing to tight spacing. So this may be an intermediate step in the long run, but that was at least getting us a little bit better data and getting us more information at these bridge structures.
Do you have any sense of why they changed the point spacing? I mean, they would work with the 300 for 30 or so years. Apparently that's been satisfactory. So what, do you have any idea what created the desire to change the spacing other than the recommendations by the FHWA or HESTA have always recommended tighter spacing?
Yep, that's a great question. So the question is, why increase the spacing when we've been doing 300-foot spacing for a long time? And as far as we know, our bridge structures are all standing, right? So, why would we need more borings? And what you said is, I think, honestly, the exact answer. Because that's what the industry's doing as far as AASHTO and FHWA guidance. That was what they felt like they had to match to get that, to be sure that we're comparing apples to apples, and since they're changing the design procedure. There's probably a case to be made that, well, did we have a better design procedure before if we could do it with fewer borings? I'm not going to go there on this topic, but I think the short answer is it is mainly because of the AASHTO and FHWA guidelines.
And maybe because we funded, if they weren't followed, you'd see it as much funded.
That's correct. And I think that is a big push for a lot of this, making sure we're in line with the industry. The field sampling procedures, other big change in the manual. If you were familiar with the Texas cone test, it is now gone. If you weren't familiar with it, not really a need to learn it. You're good now. Although, actually, I will say sort of, because when we're having bridge widening projects, we are seeing the districts and bridge division wanting us to follow the same design procedure of the previous. So they're wanting to look at the TCP data when widening a structure. It's probably not going to be all the time, but just something to be aware of. It's probably not officially gone. It'll still be there a little bit. So what we're doing instead, which is what is pretty standard across all the United States, is doing standard penetration test, SPT, with a split spoon sampler every 5 feet. This gets you the in-value blow counts that we use for our design. And then we're adding the Shelby tubes in between. So before, in our clay soils, we pretty much do Shelby tubes all the way, and the TCPs were what we do at that 5 feet, which do not collect a test. Since your split spoon's taking an 18-inch sample, you'll have to get Shelby tubes in between if you're wanting to do the strength testing on an undisturbed sample. And then rock pouring, the expectations are increasing a little bit there too. Again, we're not getting Texas cone data, so we're not going to be able to use that for design in the rock sections. So again, pretty standard for the rest of the US, but we want to get photos of that so we have good data. We want to get tests of the rock as well and get better descriptions in those rock formations, because that's what we're going to be using for our design now instead of the Texas cones.
Are there any exceptions for shale? I mean, Oklahoma DOT does the cone because of the difficulty getting samples, and the same way with our shales. You may not recover anything, and you have either you run a split spoon in place of a cone.
Yes, and there is not guidance in the manual for doing the TCPs or the Texas cones in the shales. It's a very valid point, because it's a little bit of an art to get those rock cores out. And even when you have the best driller who's really good at collecting soil in there, you still will get bad recoveries. And that even goes for some of the shales that are intermixed with the sandstone, because sandstones will wash away a lot of that. It's in the Woodbine formation here locally. So it is a challenge we're going to have to get through. If we go through the SPT method, we'll be just designing it at the highest strength that a soil could go to, which is going to be lower than what the rock is actually capable of. There's not guidance in the manual for how we should handle that right now. So
True.
yeah. Laboratory testing, we're going to be more reliant on laboratory testing because that's what we're going to be using our design on. So in the soils, we'll be wanting to use the unconfined compression test, unconsolidated, undrained, UU test, C consolidated drain, direct shears, especially when you're getting to deeper soils where you want to get a better model of what that strength is and not just rely solely on the SPTs, which you shouldn't be doing in cohesive soils, which is all outlined in the manuals. Strength of the rock testing, which discussed before, again, we're going to want to be getting that for the rock. So we get values we can use for our design. And then the going into design specifically. So previously we used these wind core plots. The Texas cones were plugged into them. Lab tests went into it too. It kind of ran a little algorithm. You could do lowest, average, all these different things, but it popped out a curve based on the borings that gave you the curve for capacity of drilled shafts or driven piles. So that's now gone. That software is not going to be used except for maybe bridge widenings like I discussed before. So we'll be using the resistance factors. I just had a snippet here. You're not going to be able to read any of that, but the point is they have a bunch of different factors you can use for different conditions that will apply. And it's very, very similar to allowable stress design, and that you're taking the capacity of that soil or that rock and then applying a resistance factor to it, and you get your unit skin friction, your unit bearing. So it's not totally different, but slightly different in the approach and just following the steps within the manual of the AASHTO manual.
Well, has TxDOT given any guidance for capacity curve, or are they leaving it to the consultant to how they present recommendations for a shaft design?
In version 1 of this manual, they're leaving it to the consultants for how to present that. I anticipate we'll probably get a little bit more guidance in the future on what plots they want to see or how they want it plotted, because there's no guidance in there about, hey, you should plot it this way and, you know, do them in however many different increments of feet, whether you break up your layers different ways. So it'll be interesting to see how it evolves once the districts start having some of their input. And one thing I should point out here too, I think it's a good time to do that. The bridge division is the one that issued out this manual, and then TxDOT is broken up into districts across the state, and each district tends to have its own standard operating procedure that adds to how the manuals work. At this time, I'm not aware of any district that has officially released a new standard operating procedure that addresses this manual. There may be one I'm not aware of, but they're kind of slowly getting to that. And I think that will add to some of this. We'll see where a district says, like Houston, who's going to have all soils and clays, hey, we want these plots plotted out so we can see how the capacity curves are changing within the soil. Dallas and Fort Worth may say, hey, most of our stuff is in rock. We don't really care about how it's plotted up on a curve because we're going to design in the rocks anyway. I don't know the answer though. That'll be what we'll have to see. I know. Told you, I'm not official. This is all just fun today. Nothing exciting. Another big change is we got the foundation notes sheet. This also has not totally clear guidance on how we're going to fill this out, but the general concept is there's a new sheet that will go into the plans where we put in how we came up with the calculations for the capacities of those drilled shafts or driven piles. And that way in the future, someone could hopefully back calculate what's going on that bridge structure. Now, I think some of you are probably already thinking about capacity curves. How is that going to look? How are we going to condense that all down onto one sheet? I think that question is still a little bit to be answered. The idea is this to be just some guidance, since the geotechnical report is often not there 30, 40 years later with the plan set. So that was kind of what I think they were going for here. But what we actually put on this, I think, again, will end up being a district-specific SOP situation, would be my guess. But that was the intent of this new sheet. It will be required on all plan sets. And then for retaining wall design, so this one is a little bit different because now all the load factors are going to come from the geotechnical industry. So when you're doing this design, which is similar to how you did external stability before, the earth load of the retaining wall, the live loads, you put all that into your calculation and decide what the bearing capacity is, sliding, overturning R for that retaining wall. So similar approach, those loads and the different factors of safety in the allowable stress design were all tailored to when you're doing sliding, let's discount the weight of the soil because that's going to increase your sliding resistance. So you look at different types of loads for different cases. They do the same thing here where they've got a max side and a min side, and you're applying that in different scenarios, whether you're looking at the sliding, whether you're looking at the overturning, or the bearing capacity. So again, pretty similar to allowable stress design, just following different language and parameters.
Stability is still ASD. Global stability is still ASD.
That is correct. Sorry, I missed that on the slide. Good thing to point out. Global stability is still allowable stress design. I'm not aware of anywhere where they're trying to push LRFD design. One DOT I know that kind of tried to was South Carolina. And what they simply did was said, report the reciprocal of your allowable stress design, just so it's a resistance factor and everything looks the same. So I have not seen anything where they're trying to do anything more than that in global stability. And then they are incorporating a new temporary wall DD sheet. So that was highlighted more in this manual. So we want to be outlining what temporary walls will be in here. The sheet is different than the MSE DD sheet. A few different parameters on there, but just something to be aware of. If you're doing your projects, be on the lookout for temporary walls. We should be adding them into our discussion for our reports.
Which are they different?
How do they differ?
How does that DD sheet differ from regular MSU wall DD sheet?
It's got a few different columns in it from the MSC DD sheet.
Was this assuming it's all cable? It's all attached?
That's the reference they're using right now. We could probably go into temporary walls into a lot of discussion on that, because there is some debate on the point of temporary walls is to let the contractor be more efficient in the design of them, but then also we want the engineer to be responsible for them being designed appropriately. So when they're doing the staging of construction, we're not worried about something being too thinned out. So there is this kind of weird balance with temporary walls. And I think this was just trying to capture, making sure we're looking at it, because it was oftentimes we missed the temporary wall, 90% design. Someone says, oh man, you're right, we're gonna need a temporary wall in here. They draw it on the sheets, never tell the geotech, and it goes straight into construction without anyone have looked at it from a technical standpoint. So I think that was at least them trying to say, think about it, please. Yes. Yes, that's correct. So it'll be for the contractors will still be responsible for part of the design, just like MSC walls. Yes.
On the DFI,
Mhm.
slope stabilization, shoring committee, that's a big topic of discussion.
Yeah.
It's how best set up for the design, contracting, as I understand it. That's what like this.
Frank, you have something?
In ESD level, we have a factor safety requirement. Our structures are lower than the permanent structures. But in LRFD, do we have a separate factors for temporary structures? Or we see we only say that?
Still the same factor. So the question was, do we have different factors for temporary structures than we do permanent structures? As of now, in the manual, we're designing them all the same. There's not guidance for a lower factor of safety with temporary structures. There is still the language on for slope stability. You can do a 1.5 factor of safety because it's still allowable stress versus a 1.3 if there's nothing critical. And critical is still, got to decide what critical is and not. I'd say most of the cases, the slope is there. It's probably critical, at least on the top or bottom. But at any rate, that's the current guidance. There's no additional thing for temporary walls. And then kind of last highlight I have here for the design side is the high mast signs. So if you're familiar with the way these are designed, TxDOT has some charts that are associated with different structures, whether they're overhead signs, high mast structures, where you pick up what the embedment of the foundation should be based on the Texas cone data. Just talked about, we don't have Texas cone data anymore. These charts have not yet been updated. So what are we doing? There is a Texas cone to SPT conversion. So that's one element that'll be going into it. And at some point, they will be replacing these with charts that are associated with the new design procedures. It probably won't be strictly SPT because you're in rock, you won't have SPTs. But I'm not sure how they're going to handle that. So they're still waiting to release those new charts. For now, you can use this conversion set. And if you're in rock, I guess you'll just use the highest version of SPT is kind of the guidance. So I'll shift here a little bit. And this is where I'm getting a little bit in my opinion piece on this topic. So if you disagree, that's fine. We can be whatever on it. But I want to talk about kind of where we're going as an industry and kind of what this is showing us. So LRFD, like we talked about, was starting to get developed in the 1960s. And here we are in 2025, TxDOT is finally adding it as a design procedure for geotechnical. There's a pretty wide range of that getting from A to B. But of course, now we're moving a little bit faster. Computers are going on. There's all this talk about AI and data centers and what that's doing to our industry. So what does that mean for us? And I think a couple things are the TxDOT resistant factors. We're going to see those get incorporated more detailed. So I expect that they'll have regional specific resistance factors that come out, structure specific and testing specific. Some of this is in AASHTO, but there's no reason that we couldn't do that specifically for Texas, right? We know it's a unique, diverse state of geology and the way we design stuff. We can tailor those design factors to how we're doing it. So I think this is something that we may be seeing in future versions to help us be a little better and thoughtful on our designing. The other thing, and this is actually changed in the manual, I didn't really highlight, but I wanted to put it on this side. TxDOT has these new logs, right? So wind core's gone. So they're trying to let the industry use whatever program they want to use, but still come out with the same format that they'd like. This is not unintentional. So what they would like to see is all of this data get loaded into a database so that they can actually start using it for future design projects. Having those uniform descriptions, uniform tables, and I think we're going to see digital delivery start being more of a thing with TxDOT for geotechnical. Yes. It is. The DIGS format is in mind. I don't think it's actually in the DIGS format, but yes. Yeah. It's background, and you're tying me into my next slide. So I'll just go ahead and go to that. So one of the things that's been going on, if you've been around the geotech world, you've probably heard of DIGS. You know, I would say first, you might have an opinion right off that says, man, this DIGS thing has been going on for a really long time, and I've seen nothing out of it. No one's using it. It's got really slow adoption rate. You know, I'm going to put that on the back burner. I'll bring you back to what we talked about at LRFD earlier, right? We just take a while to adopt these new technologies. And I still see that the way we're heading, and with us getting more digital in the way we deliver things, something, whether it's DIGS or something else, will be realistically what we're having to interface with in the future. So there will be some kind of database, certainly from our public entities, that will have this data put in, and we'll be expected to use that as an industry to some degree. That doesn't mean we're going to quit drilling, doesn't mean we're going to quit testing, but I do expect this to be a future item that we will have to deal with as an industry in our design and consideration. And it should make it better. Yes, and there are DOTs that are already doing that. That's exactly right. So I see this being a no-brainer that will be coming down the road probably sooner than we anticipate. And then the other thing for our delivery process, we kind of touched on a few of these things, but I just think digital delivery, we're here TxDOT talking about it, and I think it's going to be coming for geotech in a bigger capacity. I'm already hearing that they want to start having us send over files for our boring logs in CSV format or in AGS format or some format that they can use to incorporate into their database, which makes sense. But I don't think it'll be too long before we're delivering more than that into the database. Maybe laboratory testing, results from that, maybe even our analysis and recommendations turns into some kind of digital delivery, underground mapping. You know, these are things that kind of seem maybe a little bit out in the future, but some of us are kind of doing them on the background anyway to help support our designs, and we just present a 2D graphic in our reports. So I see this eventually getting incorporated more into plan sets, more into the digital delivery. How that looks, that's a crystal ball that I don't have. If I did, I'd be all in on it because that's the way we're going to head. But I don't know exactly what that's going to look like. But it's something I think we should be prepared for as an industry and be open to, because I think it's going to make us better overall, having this delivered in a way that's easier for our contractors to read and build, because that's the goal when we're making our recommendations, is them actually successfully building what we ask them to build. With that, I will let the rest of the time, which we've ended early, to be some discussion and questions, because I figured there's probably some extra stuff here that y'all just like to talk about. And it's in the morning, so I didn't want to take up a lot of your time in case you needed an extra cup of coffee before the next group. So thank you. Anything extra?
When's TxDOT going to start operating the contracts?
Oh, another crystal ball. I don't. You know, one thing that it has been interesting about this manual is it came at a funny time because they rolled it out. They kind of got us all excited about it, and we were ready to go and start doing new projects. And then we quit designing stuff. So I think a few firms have had an ability to actually practice this and actually see how it's going to get adopted. But when you think about how the new contract's starting or how they roll into when you start using that design, we haven't seen a lot of this get practiced and carried out across the industry to get a lot of feedback. So hopefully with time, we'll see more and more so we can actually have some good discussion and feedback on what's working and what's not. Yes.
Do you have any information? Which method is based on the cost effective? You do ASD and analysis to done.
Well, LRFD should be more cost effective, right? We're looking at more parameters and more stuff. Now we collect more data to get it. So I guess it depends on who you ask. And if we continue to be the same level of conservative or comfort we were with allowable stress when we're using LRFD, we're not going to see a change in design, and we're going to collect more data getting it. So it is kind of up to us as an industry to take this for what it's worth and use these factors and use the statistics that are behind it to be more confident in our designs. But we still don't want things falling down, right? We want to all sleep at night.
Coefficient of variation for real staff design is like 60%.
Yeah.
So it's a rather extraordinary number. And whether or not the load factors and resistance factors really are appropriate is an open question. So it's a probabilistic kind of determination that varies with the success of with load tests, demonstrating whether or not it's appropriate values to be used. So it's particularly a challenge.
It certainly is a challenge. And the covariance and stuff helps. But to your point, if you're drilling a 6-inch hole in the ground and you're capturing, you know, that little tiny piece of data, and your next boring is 300 feet or 150 feet away, you know, two borings can give you a covariance of 60%. You know, is that really what's going on between A and B? So it's still a challenge for us as an industry for sure to try to figure that out. So
Just give some more discussion, which is for cost effective. It's complicated because we use ASP method along with TCP design formulation. Now we are using a lot of which is basically a different way of managing the risk, but we are no longer using TCP formulations, we are using speed formulations. Those are different. So there's no one-to-one comparison between this design methods to say which one is more economical. You can go either way. Unless we are going to do LRFD using TCP blockouts, then there's a comparison.
That's right. So it will be difficult to compare TCP and SPT design because you're doing something that's very, very different. I'd add another thing to that. Are costs going down? No, costs are going up. So, if we're trying to compare this out, it may be kind of challenging to really see how much we're saving because it's going to cost more, whether it is more efficient or not. So that'll be something that will be challenging as well to justify. But it should be a more thoughtful design approach at the end of the day. So that should make us feel better.
The challenge is the nominal design that you're basing these things on are really a function of the conservatism of the engineer, which may or may not result in savings.
That is 100% true. So the conservatism of the engineer weighs a lot more into the final design process than the method you use, which is
Apparently, we're not alone.
true.
Can give you the reason.
Yeah. What's the saying? If you ask 10 different geotechnical engineers for design approach, you'll probably get 14 different answers. So yeah, I think that's true. Anything else?
A setting with talking about whether or not non-circular searches, you could actually justify a lower factor of safety because of the more precision in the analysis. And so could you argue that you ought to be using 1.3 or do you still use 1.5?
It's so the comment was whether you're using different slope
Non-circular
shape,
searches.
non-circular searches can use a lower factor of safety when you're and I think this goes to that experience piece. I would say if I'm driving down through the middle of town on 161, no, because we see those slopes all failing, right? And whatever they were designed to probably looked good on paper, but they're not working. But somewhere else, it might be different. So adding that experience factor is something that just can't be replaced, right? The numbers are good on paper, but how it performs in the field is another thing.
Yeah. You select the parameters that
Right.
you use and use your base to design.
And fully softened models and all that stuff. So. All right, is it time? Do I need to
You've got
pass the
5 minutes left.
5 minutes left? Okay. Or everyone can go get coffee. So it's up to you. I'm not offended if you get up and walk out. So- Okay, go ahead.
Since I've been in Texas, a lot of times we don't hear about change orders in the field,
Uh-huh.
right? So if
You don't hear about change orders?
we don't hear about,
change orders. Okay.
I mean, obviously.
Yes, okay.
And those change orders are in massive, in millions, right? So on the discussion that we had earlier, the shorter boring, the spacing wise and a lot of testing, I think that would help in respect to lowering the change order or lessening the amount of change order. So that's my perspective on it. And
Sure, it certainly should, right? I think you'll still have cases where there's an argument to be made, an argument will be made. So, but it should help with change orders, certainly.
Any questions, comments? Thank you, Roger.